In this paper, we present a new high dynamic range compression method using guided local linear constraints to automatically suppress global contrast while preserving local details. When directly rendering a high dynamic range image on an ordinary display with only modest contrast, some pixels of the HDR image appear saturated. Details are lost in the very bright and dark regions, as shown in the blue rectangles. A linear function can be used to globally compress the high dynamic range. For simplicity, we will refer to this function simply as a line. When the slope of the line is set to a small positive value, the pixel information in the dark regions is lost. If we increase the value of the slope, more details in the dark regions are shown while many pixels are saturated. So we propose the local linear models. We provide guidance on the slope of the lines. For the highlighted dark region, the high slope value of the line can help to increase the local contrast. For the highlighted region containing abrupt luminance change, a line slanting downwards can be used to reduce the high local contrast. If the highlighted bright region contains details, a line with a relatively small slope should be applied. Our automatic method operates on local small windows. These windows overlap to propagate the influence of the local constraints by solving a global optimization problem. Our optimization problem is solved iteratively on the luminance channel. The local constraints are efficiently propagated to produce a globally optimized result. This is our result after reconstructing the color channels. The dynamic range compression results are presented. This is the Memorial Church example. It contains complex architectural structures. The light through the glass windows and clerestory illuminates the church unevenly. Here we show our tone mapping results. The patterns on the stained glass windows can be seen clearly. The originally very dark regions, such as the top left corner of the image, are enhanced. Other details, such as the paintings and textures, are preserved. We show the tone mapping results from other methods. We show the synagogue example. This is our tone mapping result. The gate and pillars, as well as the details on the roof and the entry, are clearly visible. Other tone mapping methods also perform well in compressing the high dynamic range of this example. We show the published results for comparison. Here we show more dynamic range compression results generated by our method. The details from all ranges of the luminance are revealed without introducing visual artifacts. Our method can be readily applied to other tone management applications. We first show the application of enhancement. Our method can enhance an ordinary image having either of the following problems. The first is underexposure on the object of interest. Another is the lack of contrast, making the image look washed out. Several examples are shown here. The second application is the realistic HDR image synthesis. Given an LDR image, we synthesize an HDR image by exaggerating the local contrast. Here we show several examples. This provides the user with an alternative way to create HDR images without requiring the setup of the HDR image acquisition environment.